to our next session, which is to introduce the CEC's latest industrial, agriculture, and water low flexibility hub. This project is led by our CalFlexHub partner Momentum, and so these are sister hubs, right? Sister hubs, and really, in CalFlexHub, we are covering the building sector, and then we don't want to miss the big players in the industrial, ag, and water sectors as well. And so before we get into the next session, I want to invite our CAM, Mr. Matt Fong, to the stage. So Matt has been a tremendous partner for the CalFlexHub program. He is the commission grant manager. And Matt, I want to thank you for your partnership for the last, it's been more than 5 years. Yeah, this solicitation was formulated and with David. There was a shout out for David. That vision from 11 years ago, and that's more than what I knew. So thank you for that. And so Matt, I think you were a key member of how the solicitation was formulated, the original vision. And I personally feel extremely fortunate that we have had 7-8 years of continuity working with you so that none of that original vision is lost along the way, because it is the continuity that you bring to us, your continued support. It takes a lot of experience. I believe you're probably one of the most experienced CAM on the CEC's low flexibility team. And so your expertise, and takes a lot of patience too. This is a really huge program that has a lot of mass to it. It's not a ship that can take sharp turns. And, so we work together through a lot of really great challenges over the years. So our LBNL and partner teams, sincere thank you to you. And I want to give you an opportunity to say a few words.
So thank you, Jing, and good afternoon, everyone. As she mentioned, I'm the Commission Agreement Manager for CalFlexHub, and we've been working on this concept for over 5 years, because there's this GFO concept phase, and then the execution of the GFO, and then obviously the 5 years that we've been here all together. So this GFO that created the CalFlexHub was kind of an innovative approach to how we normally do EPIC grants. We wanted to have kind of a multidisciplinary team that could easily pivot between projects and concepts depending on how project results came out. And so I personally wanted to thank Jing, Marianne, LBNL team for bearing with this new process and bearing with me at times. As Jing alluded to, this is a challenging but very fruitful project that we're coming soon to a close. So I just want to. And not only I want to thank the LBNL team, but I also want to thank their project teams, their partners for all their CalFlexHub successes. And as I mentioned, we started on this journey with CalFlexHub, the project phase in 2021. We're in the middle of a pandemic. Many of you probably remember that the first symposium was completely virtual, and now here we are in a hybrid in-person environment. Navigating those tricky times while also tackling this very important energy topic of demand flexibility for residential and commercial buildings is no simple task. Without their stewardship, we would not have advanced the controls and communication technologies like the adoption of control algorithms by industry and utility programs, as well as spearheading the development and adoption of OpenADR3, as well as a much needed critical flexibility evaluation framework, and the important stakeholder and market assessments you heard today and in the past symposiums, to bring us closer to realizing California's 7 gigawatt goal, load shift goal by 2030. However, we are not finished and there's still work to be done, barriers to be broken, and value to be captured, especially by those who have been historically underserved. The lessons learned from CalFlexHub are impacting the direction of the demand flexibility research and the EPIC 5 investment plan that's coming up. And that investment plan is currently under development to help California realize greater capacity and greater reliability. The CalFlexHub achievements will continue to improve and evolve through EPIC and beyond, but the evolution does not stop with residential and commercial. Much of the foundation work, like the experimental rates and the control strategies, can not only be adapted to end uses within residential and commercial spaces, but also the industrial, agricultural, and water sectors, which have huge potential for demonstrating demand shifting. Our EPIC Demand Flex team realized the technological successes of CalFlexHub and have the potential to be realized in the IAW space. And so in 2024, we developed the solicitation to fund a new hub that deployed technologies to move more ready for market adoption of in the IAW space, and really focus on improving the business cases for demand flexibility through larger field deployments that will result in more scalable solutions. IAW FlexHub seeks solutions to increase consumer awareness, reduce cost of implementation, deploy predictive controls of automated demand flexibility, and demonstrate state-of-the-art practices of interoperability. And for these reasons, IAW FlexHub was born. And now I would like to invite the panel up. So I would like Akriti Gupta, who's the Commission Agreement Manager for IAW FlexHub, Matt Hart, CEO of Momentum, and Jessica Granderson, Senior Scientist, Senior Scientist Director of Building and Industrial Energy Systems Division at LBNL.
All right. Hi, everyone. Thanks, Matt, for introducing this and for being a key architect for IAW FlexHub. Matt was the solicitation manager, and so that means he wrote up the entire GFO with obviously the help of a ton of folks at the CEC. So yeah, very grateful for your leadership on this. So I have prepared and short remarks because I want to leave a lot of time for us to go through the structure. So as we noted earlier, CalFlexHub has laid a very strong foundation in proving that coordinated research and partnerships can turn emerging technologies into real-world deployable solutions. And now we have the Industrial, Agricultural, and Water Load Flexibility Hub, which I'm henceforth going to call IAW FlexHub because that's a mouthful. And we hope to build on that foundation to scale flexibility in California's largest load sectors. So while CalFlexHub focused on establishing foundational methods and technologies for buildings, the IAW Hub focuses on deployment at scale, larger, more complex systems with high reliability, safety, and production requirements. So just to get into a bit of the requirements that I mentioned, IAW facilities operate some of the largest, most energy intensive, and most continuous loads in the state, and yet these sectors remain some of the least understood when it comes to actually operationalizing the flexibility. As Sarah mentioned earlier, there are different motivators in these sectors, there's different behaviors, and unlocking even a modest amount of flexibility from these very high impact loads can yield major system benefits in both reliability and affordability. So it's essential for us to move beyond buildings without necessarily leaving them behind, but move into the IAW sectors given our state's 7,000 megawatt load shift goal. So the IAW FlexHub was created to fill this critical research and deployment gap in demonstrating these technologies and strategies, focusing mainly on strategies that are ready to be commercialized and ones that IAW operators can adopt with confidence moving forward. And similar to CalFlexHub, it was this hub is designed to also bring together a multidisciplinary coalition of researchers and industry professionals. And we're probably going to hear more about that later, I assume. Great. Okay. Then I won't get into it. But we're structured intentionally to be iterative and adaptive based on project results, evolving policy needs, and also input from technical advisors. So that's a key part of the hub. It was a key part of CalFlexHub and continues to be for this one as well. So just to quickly get into some of the sectors that we're hoping to see projects in, and but also this is a not comprehensive list. Chemical processes, all kinds of manufacturing, water treatment, other types of water facilities, any types of what we're constituting large loads, which probably includes data centers, but may not just be data centers. Industrial irrigation or industrial pumping and agricultural irrigation. So those are just to name a few, but I'm sure I'm missing some. So please, folks in the room, fill in the blanks. But yeah, the IAW FlexHub has several core research priorities. I won't get into all of them, but maybe just a few. One of the major priorities is to conduct a statewide load shape and operational flexibility assessments. So building on the DR potential studies and building on a lot of the other data assessments that LBNL has conducted amongst other folks, we want to fill some of these longstanding data gaps. And then also another big portion is demonstrating signal responsive, cyber secure, automated controls that are capable of responding to grid signals. I saw cyber secure get a little nod. And yeah, so generally we're looking at trying to reach commercialization, lower implementation costs, and demonstrate interoperable, scalable solutions. So the opportunities are massive in this space, and I want to turn it over to Matt to take us through the hub structure and the plans.
Now, yes, good. I have to be shorter. All right, how about that? We'll do the whole hold it thing. So we put this here at the end of this symposium mostly as a test. We wanted to see which one of you were into load flex everywhere. And now we know, because you guys all passed here in the room, everyone else who left, we know they're just in it for the resin commercial segments. So Matt Hart, CEO here at Momentum, we're the administrator for the IAW FlexHub, and happy to spend a little bit of time announcing kind of what the hub is, what the expectations are, and then turning it over to Jessica to talk about some of the projects that we'll be doing. All right, so just like the rest of us here, we're all committed to helping the state achieve its goals. I think a big difference here is that we are focused specifically on that industrial, ag, water, larger load segments. I think as Alexandra had mentioned in her conversation, getting industrial segment to actually participate in this is particularly challenging because of the nature of what they do and how energy plays into their businesses. And this really is a sibling organization, something that we are building off the foundation that CalFlexHub created, and expanding the reach of this type of a program and this type of consortium to drive change in the industry. So just to get a sense of some of our partners, we're very appreciative of the funding and the starting of this that came from the California Energy Commission. And we appreciate our support and from our utility sponsors, SCE and PG&E. So thank you both for contributing to this. Right now, as we've gotten started and got launched, we have 7 research partners, and we have our first 3 demonstration partners. So what to expect as we're getting into this and we're launching this new program? First, we're starting our initial activities with some centralizing activities, some centralizing work. As Akruti mentioned, the market assessment is something that Berkeley Lab will be leading, and we'll hear more about that next. Really around diving deeper into this segment, better understanding the data, and helping drive decisions into what are we going to spend future funds on, what is going to have the most impact. We're working with our partner, PSE Healthy Energy, in order to look at the community framework and how do we approach load flexibility, the benefits to the community, when we're really talking about these large users, these heavy industries that aren't quite as clear cut about how demand flexibility will help the individuals that live around where this is happening. And then our lead DNV is working on measurement and verification. So we have a standardized approach to looking at that across all the projects in the hub to help us better aggregate and understand the cumulative impacts of the data that we're receiving. And of course, demonstrations. And this is really about making sure that we're tackling a lot of the barriers, moving beyond the hypothetical, the theoretical, and getting this out into the market to show what's working, to show what the impacts are, and to make sure that as a group, we can look at what the challenges are. Specifically, we're looking for near commercial technologies that we can advance and get ready to move into scalable commercial markets. We do in our demonstrations want to have all of them enroll actually in flexible programs and tariffs to make sure that we're showing it live. And then also show the cost savings, the payback that we have from this to make sure that we're aligning the investments we're making with activities that we think the private sector can actually adopt. So, do we have room for more demonstrations? The answer is yes. We do have an open call that is up right now, and this is really about trying to understand who's out there who is interested in demonstrating demand flexible technologies. It's okay if you don't have a fully baked project. It's okay if you don't have all the pieces together. We want to make sure that we're gathering interest from all those who seek to participate. We can help connect teams together to make projects. So we really want to encourage folks to express their interest, however well or however little developed it is, into these demonstrations. The application is on our website, iawflexhub.org. And if we go to the next slide, if we go to this QR code, we will also bring you to the site where the applications are. So as we're getting this launched, we have a number of different ways to be engaged. There's just ways to send us messages directly, join mailing lists. We have 3 different stakeholder working groups that'll be focused on different topics and thinking about what are the things that we need to tackle within those different stakeholder groups and help overcome. And then the concept, the open call for concepts as well. So we're looking to figure out what are those next projects going to be. Our hope is we have a lot of interest here, so we can, it'll be tough to figure out which ones move forward, but we want to be able to show the interest here. That way we can think through what's next. And I think the CEC will get some more insights as to who's excited about things, so they can think about how they direct funding with that as well. And then it is the beginning of Flex Week for those of you who are really conference junkies. We're starting here. We've got our partners at UC Davis with their industry and materials event. That is a free in-person event up at Davis that I believe a number of folks will be able to make it to. And then a specific IAW FlexHub launch event that will be in-person and virtual for those who need to get home at some point in time. So I hope to see a lot of you guys there as we can go through some more information about that. And then just a sense of who our team is. Kula is our project lead right here. She's over there, doesn't want to look. So hopefully we get to hear from a lot of you, but just wanted to put some contact information out there. And with that, Jessica would like to turn it over to you.
Well, thank you all for having me here this afternoon to join you. It's very exciting to be standing up this hub as a lead performer alongside UC Davis and EPRI under Momentum's leadership with the full hub-wide team of performers that they have assembled. Go next. Akriti, you spoke to this a little bit. This is really the time before us to really triple down on our efforts with the industrial, ag, and water sectors. This is kind of the 3-2-1 story. You know, California is the third largest electricity consumer in the whole country. The industrial, ag, water sector is the second largest end use sector in the state, right? Second to transportation, and therefore really center path to meeting our goals. And then number one, right? Just as we speak of affordability in the commercial and residential context, our rates are really high for industry as well, coming in at more than twice the average of all the other states in the country. This all really speaks to the tremendous impact that is in front of us in advancing the next generation of demand flexible strategies and solutions for this part of California's economy. We've been extremely fortunate here at Berkeley Lab to build up really full stack world-class capabilities in demand flexibility. I want to very explicitly acknowledge that this has only been possible through a combination of three things. The first being the really early and sustained R&D investments from California State here at the lab that have taken us from the first very early implementations and demonstrations all the way into today's policy frameworks and program ecosystem. The second is our strong partnerships that span the full demand flexibility delivery chain, all the way from customers into the technology and service providers who they work with, the utilities and our state regulatory and planning bodies, represented by many of you here in the room and online with us today. Third, very much our serendipitous position as a DOE national laboratory located here in California State. That has really afforded us with the connective tissue to link the activities that are happening here with those on the national scale. And like two examples that illustrate that, throughout the course of the CalFlexHub, we were also working closely with our DOE partners to develop DOE's national roadmap for flexibility in buildings. We're standing up now the IAW hub, and similarly at the same time launching the DOE's Reflex program, which is simultaneously pursuing aggressive near-term uptake in flexibility adoption across the whole country. Within the IAW hub, Berkeley Lab is involved in demonstration as well as a hub-wide market assessment that was referred to by both Akriti and Matt. So I think of this as really the next arc in a segment of state and national studies that will allow us to drill even deeper into those IAW sectors, understanding how they affect the grid, the benefits we can realize by bringing more flexibility to them, and the value proposition of key technologies. Our prior work in the DR potential studies and price response potential studies showed first, just some highlights and real top line, over 3 gigawatts of shed DR potential in 2030 across our 3 IOUs from agriculture and industry. Those are shown in the stacked bars, every row being 2025, 30, 40, and 50. You can see industry and agriculture in the kind of army green in the first slot on the stacks there. Also, oh, thank you, Matt. Also the gray. and a small sliver on top of the gray that would represent industrial pumping. We also showed that just if you look at dynamic price response only of crop irrigation, there's a gigawatt of peak demand reduction to be had there, with benefit back to the customer of thousands of dollars per meter per year. As we move forward, we're going to start under the IAW hub with a more resolved characterization of electricity demand patterns. And we get to do that with data that we've never had access to before. All meters across 4 utilities statewide, spanning from 2019 to 2024 time period. So here we're going to be able to look at different operational schedules, coincidence of peaks with overall grid peaks. We can investigate variability, seasonality. Some of these plots here show the kind of thing that we're after, albeit clustering of different load shapes from a much smaller data set that only represented a smaller sample of what we now have available to us. We can look at patterns across subsectors, different facility sizes, locations, et cetera. What that's going to feed into is not only targeting of flexibility interventions, but then a statewide model to evaluate potential. So we use these load shape patterns and characteristics to look at, create future demand forecasts, and then estimate the total aggregated statewide potential for both shed and shift. Now, this is going to be complemented with a bottom-up determination of a value proposition around specific technologies of relevance to these sectors. We'll do that in coordination and partnership with the demonstration teams, the idea being to look at the load response available through those technologies under different either pricing or program scenarios, understand the cost benefit back to the customer in terms of cost balanced with potential bill savings. In addition to the hub-wide market assessment, I wanted to talk about a demonstration that we have lined up that I am just really excited for. This is with Siemens. This is an all-electric factory. What's so cool, we don't often get this opportunity. So Siemens is participating as the site host, their factory. Siemens also has tremendous presence in the industrial automation technology space. So we kind of have them coming together, completely different business units, both sides of the table to partner with us in this work. This facility is photographed here. It's in Edison territory in Pomona. It's just shy of 150,000 square feet. And really fun assets on site. So there's on-site solar serving about 30% of the load, 500 kilowatts of battery storage. And in this demonstration, we're going to look at actually 2 technologies. They're both nearly market ready for the applications that we'll be putting them to use for. The load management application, and then the BIOS, which I'll talk a little bit about what they each do. The other thing I want to draw out here is we've talked about the continuum of these hubs and sister hubs, our work in particular, commercial sector and campuses. And there's very strong synergies to exploit. So these technologies are not only applicable to the industrial sector, but also to those campuses and commercial facilities. We'll be looking at multi-asset control orchestration across the HVAC that's there to condition the factory, the presence of that on-site generation, the battery storage, and potentially the hot water thermal storage that's there. This facility is producing low voltage electrical equipment. And so there is a powder coating process which they use for the safety properties of the electrical equipment. So the hot water storage is used to serve those process loads. And so we'll explore how that asset can also be brought into the mix. We're going to look at shed and shift potential as well as continuous demand management. I think that's more of actually what brought Siemens to the table than even the like industrial product line. Like they have an all electric factory, and that makes the economic considerations and implications extremely important for them as they and it's a brand new factory. So we're going to look very closely at costs and benefits and those real world operational constraints that will certainly come into play in this operational facility. So step one is going to be to deploy technology one, that's the load management application, and start exercising the HVAC loads in the facility. So this is a multi-stage effort. We'll automate the peak demand limiting and automated DR through this technology. Then we'll pull in a technology called BIOS and integrate the two together. BIOS is a pre-commercial optimization platform. It's being adapted from other application spaces to be able to integrate open ADR, to support CAISO participation, and to really bring it front and center for the US market. With that technology, we'll be able to use predictive models to do day ahead and real-time dispatch of those on-site resources. The third step is going to be to explore how we can enhance things even further, bringing even more integrated, coordinated control to those systems beyond the algorithms or approaches that are currently kind of baked into the suite of approaches in these pre-commercial technologies. We'll look at how the thermal storage, the battery, the PV, and the HVAC can be brought into more consistent, fully integrated control and validate those in modeled environments for further adoption. The impact here is first that novel technology integration across the two platforms through which we expect to bring up to 250 kilowatts of demand reduction, to also bring those bottom line energy cost savings through the continuous demand management, somewhere around 5 to 12%, and do that with less than a 5-year payback. We'll mature those pre-commercial technologies to full market readiness, making sure that by the end of the project, we have demonstrated their coordination and ability to serve in these intended application spaces with really replicable deployment pathways for other industrial customers beyond this particular Siemens site. Where we explore moving even farther in predictive integrated control that can enhance these technologies, then we will provide those in open specification format so that they're available to any other technology providers who may wish to pick them up in their product lines. We will be working towards that first installation of technology number one, focused largely on the conditioning systems, getting that fully installed by the fall of this year. And then by the fall of the following year, 2027, we'll expect to have captured all the data and understand the performance impacts of that system in operation alone. Then the next stage is bringing in technology number two for the cross-asset coordination. That will be conducted through 2028 with the data of performance captured by the fall of that year. By that time, we will also plan to have done the full exploration of the role and presence of that thermal energy storage serving the process loads and how it could be brought into the mix for further benefit. The analysis should be complete by fall of 2029 with conclusion of the effort in full by spring of 2030. I too want to acknowledge the fantastic team that I get to work with here. And I'm sure folks in the room know some of these people. Stacy Curry is our program manager. Dong-Hoon Kim is leading the Siemens demonstration, technology development work. Sarah Smith conducting, of course, the market assessment. And Jingjing Liu is co-PI in this project, touching all aspects of it alongside me. Thank you.
All right, thank you, everyone. Now we have time for Q&A. If you have pressing questions about the new FlexHub, as Matt said, my name is Kula Addy, and we're really just excited to be continuing the journey with LBNL and all of our partners. I do want to also shout out, I believe, Kelly, Professor Kisak, and Ben from UC Davis were here in person. They might have left. But if you're viewing and participating online, some of our partners from EPRI and PSC are also there. So you can drop your questions in the Q&A and we'll do our best to answer them. Any questions in the room?
Hi, Prashant from ASC. Two questions. One is, why are you not considering data center flexibility? Because that's the biggest load and that's a lot of, the load is large, the problem is big. And so that's one. The second is, I think CSA has a program on MDMA and for, as well as PG&E has a program on Flex Connect, where you're kind of sending control signals to the battery or battery plus other loads. And that's on the 1 to 10 megawatt scale. And that already is integrated to maybe the PG&E system. The MDMA is integrated again to the billing system. So if you're looking at controlling or modulating load, those could be pretty good initial candidates. So are you looking at that as well? Thanks. First question is, why are you not considering data center load flexibility?
We are. So that's good. That was easy. Let's go to the next one.
So the second question is, PG&E has Flex Connect program. Both SCE and PG&E. CEC program is EV submetering and meter data management agency, which is looking at sub-meter billing for residential as well as C&I customers. So there are a lot of C&I customers like Apple, Google, all participating in the MDMA program where they want to kind of reduce their EV charging, 700, 800 EV chargers in their buildings. And right now it's basically pricing signal, so you get benefit on, but this can benefit from that. So are you looking at that? That's the second question.
I think we'll see if I answer your question. We, I think, are looking at two different elements, major elements of this. One is how do we help get customers enrolled into those programs so we can continue to gather more data about how well are those programs working. How do we get more data so that the IOUs can be looking at their rate setting and think through as they look at future rates and future tariffs. How do they want to create those to enable the actual outcomes that they're looking for? And then I think something we heard a lot in the last panel is the different market segments have a lot of different needs, and there are certain programs that have worked well for a set of segments, but let's say maybe the water sector hasn't particularly adopted that. They haven't found that flexible rate to meet their operational needs. So thinking through how are we making sure we're hitting that behavior segmentation So we can look at where there are large amounts of loads, which we'll get more insights into as we're working through the deeper dive into the assessment, and actually enabling those users with those operational constraints to effectively work in the program. Did that address what you were asking?
So with regard to the EV sub-metering, I think CEC and CPUC has been trying to get enrollment on it and spend a lot of time on standardizing the EV sub-metering protocol. And it's a different team in CEC, but so there's a cost is an issue. So if there's additional incentive to the same program or the same customer, so the main is agree pumps is there in that MDMA program and EV sub-metering. So what I'm trying to say is that there are other programs that could benefit from this work as well. And so if you can club it, there could be some, I mean, you can get more teams working together as well as more potential partners.
Yeah, and I agree. Collaboration is good. And certainly if one of the things that I certainly stress, as you are seeing ideas and seeing opportunities there, if you can drop the line in through the IAW hub, whether it's through the open call and kind of talk through some of the things you're seeing, even if you get to certain sections of those questions, just say, I don't know yet. That's fine. I think that'll help us create that dialogue and create the ability to leverage the full consortium to start thinking about solutions for that. Thank you for the questions.
Hi, thank you so much and congratulations on the launch. I'm curious about your view on where DERMS plays into this equation, particularly with utilities increasingly interested to orchestrate larger loads, not residential class, not smaller systems, but larger loads through the DERMS platform. And case in point, this Flex Connect that Prashant was mentioning is also being administered through the grid DERMS, not the aggregator managed DERMS. Is there a role for all of that here in this demonstration project? And
I got it. It's me. I'm holding the mic. I think on the DERM side, there are some opportunities, but we are looking specifically at those individual type large users. So as opposed to the aggregator segment where we're creating manageable larger loads, whereas like the segment that we're most interested in is looking at those individual large loads that have specifically large impacts within their grid area.
yeah, I mean, those exact large loads are being not integrated to aggregator stuff. The utilities back-end DERM systems are the ones that can orchestrate these large loads, not the aggregator managed programs. So I think that's a very strong area to look at.
Yep.
So going back to the double dipping with the participants, I'm just curious, are there any limitations to the sites that you will consider including? So if a site is already demand response, active in demand response or hourly flex pricing, dynamic rates, can they also be part of this initiative if there's something to explore on the site?
One of the requirements is that they are enrolled in it. Now, I think a lot of the projects we have will be getting enrolled in it. That being said, it's not preclusive of, hey, you're already there. There may be certain technologies that even though they're already enrolled in it, they just are like, I don't know that I'm ready to go test this out. I'm not sure I'm ready to invest in this. That this program might help support. How do we test and validate a technology that maybe that entity wouldn't enable on their own?
Perfect. So it doesn't exclude them if they're ready. Thank you.
Thanks for putting this on. Very happy to see that. I worked on industrial ag, all those for many years, but on the energy efficiency side. We did a lot of research that actually DNV in its previous name, Kima or even Zenergy, did work. So go look at those projects. They're all at calmec.org. They explain what are their issues, what are their opportunities, what are their motivators. There's stuff that the CEC did also on large industrial customers and what motivates them to do things differently. But definitely use the key account reps and the CAMs, as they call them at FCE. These folks touch base with these large customers every day. They can bring good customers to your program and get them to participate with you and carry them along. So they're a good agent, as Mark Martinez was saying earlier, for you to consider as a partner in this effort. And I'm very happy you're doing it. Thank you.
Hi, Rich Brown from UC Berkeley and LBNL. I think one of the strengths of CalFlexHub, the Buildings Hub, is the behavioral work that Sarah Outcult at Davis has done. And I didn't see, or my question is there an element of that in the IAW Hub? I saw you're doing outreach to affected communities, but I'm wondering about behavior and decision-making within these IAW organizations. And kind of a related question is there an element of bringing strategic energy management and ISO 50001 in as an element of integrating demand flexibility into the overall organization's energy management strategy?
Great question. And I think that's something I probably could have touched on a little bit more on the demonstration side. For our early demonstrations, all of our partners are looking at not only demonstrating the specific technology or the specific strategy, because sometimes there's not a new technology, but a new strategy to managing electricity within the given facility. But part of their work is also thinking through how do we, to what Jessica mentioned, not just look at the Siemens facility and how did that work for them, but how do we consider this to be valuable for any manufacturer that needs to be thinking about that. So part of it is with the case study of the 1 or 2 demonstration projects that might be able to be funded in the program. How do we extrapolate some of those unique behavior profiles that a manufacturer might have that is very different from someone who has to supply water versus somebody who has to manage wastewater and runoff, somebody who has crops and plants. So that, as you mentioned, the decision-making paradigms are very different in these different segments. And that has been a core part of a lot of those programs. So thanks for bringing that up.
I'm handing it back to you. Just to add one more thing is PSC has done work on putting together the community impact plan framework. So all of the demonstration projects will be developing community impact plans. And while some of that work is related to the communities in which those sites exist, a big part of it is also the workforce that exists at the sites and the impacts that these technologies or strategies may have on their work and their potential well-being, for example, and also kind of the behavior of the work of the folks that are working there and how that might impact also the strategies and technologies and the implementation of that. So I think it's also that piece that's being included.
This is just additional commentary in response to Rich's question. Yeah, we don't have explicit language like in the market assessment, for example, to think about enrollment or adoption rates or that sort of thing. In this project, we'll be doing more of like a technical and economic potential study. In our DOE new flexibility project, we do have some language around trying to dive into the different drivers of what might motivate different facilities to do load flexibility. And I think Mark made a comment earlier around, industries where electricity is a large portion of their costs, and maybe industries that are operating on thinner margins, there might be more of that motivation to save on their bill. So we're pulling economic data
and data from EIA, like the MEX survey and things like that, to try to think about subsector by subsector, what do those factors look like and how might they tie to sort of a propensity to be interested in load flex. So hopefully there will be a lot of cross-pollination between these two projects, and hopefully we can apply some of that there. The other tool we've used in past CPUC studies was looking at the program enrollment data for the existing programs. That data is not part of the CEC AMI data warehouse, so we don't have that program data for this project yet, but maybe we can work with some of our utility partners and colleagues to get some insights on kind of the past enrollment patterns as well.
Hopefully quick question. So Jessica, the example you showed, right? It seems like it's a control system managing like PV battery. It seems like it's a control system managing PV battery, solar, EVs, etc. Right? The usual loads. What were you thinking of doing with regards to the process loads, the manufacturing process itself? Are you
That's the thermal storage that I mentioned. So
Okay.
the hot water storage that is serving that coating process. And so that is a component as well. So you could probably imagine that out of the gate with a brand new facility, the site is not like, oh yeah, absolutely out of the gate, please flex our process loads that are core to what we're manufacturing, right? And so they're like, even with our own technologies, Siemens being Siemens, we're going to step through first the conditioning loads with this platform, next dispatch the battery in the presence of the solar. Now we're going to start looking at the role of that process load and how we can bring that into flexing. Because otherwise what they tell us is that their goal for this facility, which is a highly automated facility, is very high throughput, right? And so that's how we're looking to address the process component in the design of this particular demonstration.
Yeah. Okay. I'm just thinking when you look at other demonstration spots too, right? Just wondering how much the process load would be flexible. Like, for example, would somebody be willing to turn off a line at peak demand, things like that, right?
Yeah. Well, on those bar charts we showed, the prior work is suggesting that that was the gray, which was pretty significant industrial processes. So I think it's fair to say that across the full cohort of demonstrations that are planned, how that manifests and looks will be different in each case. And the availability of that process load in principle, it kind of ties back to the customer motivation value proposition elements. Like, what are the conditions around which these facilities will start taking full advantage of all of the loads in the facility, and how that is phased into each of them. So, yeah.
Thank you.
We don't have any online questions, so we can take a couple more here if there are any. Okay, yeah, let's start the next section. Just a reminder that we have the April 17th launch and stakeholder group meeting that you are more than invited to. You can also join the UC Davis event. We're looking for all of your ideas. Thank you so much. Thank you to the panelists as well.